Hello everyone, I'm Mingrun from IHEP, and I'm bringing you the uproot-custom, which is a uproot extension that allow users to customize branch data reading. Okay, I'm starting at the status of teacher reading. At present, the teacher reading in uproot perfectly supports most of the teacher reading cases, but as Andrew's talk said, the teacher is too complicated to be fully supported. And now we have Untuple, which is a better choice, but for those deep users of deep of root custom classes, they still need time to transition to Untuple. So is there any way to directly read their custom classes with uproot? The answer is yes, and here comes the uproot custom. The uproot custom is not aiming to implement all the rest of teacher specifications. Instead, it just provides some tools for users to meet their respective needs, just as this figure shows. The uproot custom acts like a bridge that allows different users to achieve different demands. And this figure shows the general process of uproot teacher reading. The branch gives binary data to uproot interpretation, and the interpretation transforms binary data into NumPy or awkward arrays. The uproot custom bases on such interpretation mechanism, and this makes it can maintain good compatibility with uproot's reading features like concatenate, iterate, etc. And also the uproot custom is implemented with both Python and C++, so it can have good flexibility and performance. And now let's turn to the code. And here is an example that shows how to use uproot custom to read a class with streamer method overridden. This is also a custom class. And I need to introduce the definition of the class. We define a class which names is override streamer with two data members here, an integer and a double. And we override its streamer method. Uh, for example, in here, when the binary stream is in writing mode, we first write the object data member, write the integer data member. Just for illustration, we additionally write a tag here and then write a double data member. So the uproot cannot handle it natively because it doesn't know what happens in the streamer method. So in here, we can show the branch. And you can see the interpretation is as strided objects, which is one of the uproot's interpretation. But if you try to read the data, it will raise an exception. So the uproot custom can read it, but we need to implement some classes. And here is a general introduction of how uproot custom read data. And first, it has an as custom interpretation. The interpretation we use several Python factories, and for example, primitive factory, STL vector factory, T-string factory, and users can register their own factories here. And the factory will build corresponding C++ reader, and the reader does the actual reading task. And after the reading, it returns the data as NumPy arrays or Python tuple, Python list to back to the factory, and then factory construct the final awkward arrays. So, oh, sorry. Oh, what happened? So, in C++ reader for our T-override streamer class, we need to implement the concrete reading logics just as the streamer method did. So in here, you can see we first read the T-object data members, but actually we just skip them because we don't use them. And then read an integer data member and push back to a vector. And also remember that between the integer member and double member, there is a tag here. So we read the tag and check the tag, and finally read the double member. So after the reading process, we also need to convert our two vectors into NumPy arrays and make them a Python tuple, and then return to the Python factory. So in the factory, things will be easier. We receive the data. This raw data is equivalent to the tuple returned from here, and then construct the awkward contents. The awkward contents will be finally built as awkward array. So this is almost all the things a user need to do. So after doing these all things, we just need to override our import our factory, register it to uproot-custom system, and also we need to specify which branch the uproot-custom should be applied on. And we show the branch again. You can see that the interpretation has become to as custom, and now the data can be read out correctly with our own factory and reader. And also the uproot custom is can reuse the reader and factory we defined above to handle more complex data structures like vector or map. And also here we specify two more branches and show the T tree. And you can see that for the branch with type name vector of our T override streamer and the value of our map, they are not the single object here, and also the interpretation is as custom. And we can also directly call dot arrays to read them as a group. And there is an interesting thing that since users can know the concrete structure of awkward contents, so the factory can also build the awkward form directly. And the awkward form can be used to read our data with uproot.ask and maybe in the future with the virtual array. And I just show a uproot.ask example here. And only we call the compute will the data be read out here. And that's all the brief introduction of uproot custom, and thank you.